Okay, so today we're going to be adding some more features to Capwork. Are we going to get the side thing set up? Okay, I'll leave that by the first workshop, but whatever. Okay. So anyways, so last time on Capwork, what we did was we set up the profile page. So using some JavaScript, we were able to generate some HTML elements and insert them into the page. It makes some cool things like this navbar here. So as you see this example code, creates a new DOM element, which we learned yesterday, and inserts it into the page. So yesterday we learned about DOM manipulation with JS, which is going to be an important skill for today's workshop. We're going to extend the Capwork by adding the stories page. So that's the index.html, the home page that will show all the stories and all the comments. So to do this, all the stories are stored in some backend that we already have. And we're going to need to send a GET request to this backend using the API to get all these stories. And then with the data from these stories, use JavaScript to turn this into HTML elements that we can put on the page. So this will involve learning how to do API requests with JS, in addition to applying it to yesterday's knowledge of DOM manipulation with JS. So in this workshop, the first thing that our code for the home page is going to do is send a GET request to the API, and the API is going to send back a big JavaScript array. And this JavaScript array will contain these objects, which has information about every story. It's going to have information like what does it say, who wrote it. It's going to have an ID, which is like just a unique tag for every post. And we're going to use that to write some JavaScript code to display it on the page. So first, let's download the first workshop here. Again, do not use zip file. Please clone this. So I'll give you a minute to do that. And if you have any questions throughout the lecture, feel free to use the question sheet, which is always open.
If you guys are having trouble with cloning it, just raise your hand, we'll get you.
Anyone else need more time for this? Got it, for the time being. So an overview of what we're going to be working with today. So these are the new files we're going to be dealing with today. So first there's index.html. That's the home page of Capwork. And it's going to be the page that has all the stories in it. And right now it's kind of just a bare bones template. There's a comment where all the stories are going to go, but it's empty right now if you take a look at the code. We're giving you this next script for free. It's called API.js. And that contains methods to perform GET and POST requests. So if you're wondering how do you actually send a GET request in JavaScript, we've given you this code already, so you don't need to worry about that too much. So the most important piece of code we're going to be working with today is feed.js. Now that's the core JavaScript file that is going to send out these GET requests, take the response, turn them into DOM elements, and put them into the page. So that's the job of feed.js. And finally, index.js is the code that runs when you load the page. And this will just start up with some various bookkeeping. It'll call feed.js. It will just basically initialize feed to start. And we'll see how that works in a second. So we've given you API.js for free. But it's important to understand what we're using here. So it's very easy when you're developing to start ripping tons of code from Stack Overflow and start inputting tons of random libraries and not really understand what any of it means. But at some point, if your code totally breaks down, you're going to have no idea how to fix it because you just stole all your code and you don't understand it. So we're going to take a few minutes to go over API.js and make sure we actually know what's going on. So I'm going to take a mini exercise here. So we're going to pause for a few minutes and open up API.js. And we're going to keep these questions in mind. All right, so. And it's not important that you understand every line, but just generally what's going on. So in a few minutes, we'll go over these questions. want some more time to stare at it. All right. So let's try to go over these questions. So can anyone tell me, so what parameters do these get and post methods take? So, yeah, Matt.
The get function takes an endpoint, some parameters, a success callback, and a failure callback.
Yeah, so as we saw last time, the endpoint is basically the URL to which we're going to send this GET request. Parameters is going to be some data. You might need to send along some data to the GET request. For example, if you're trying to get, if you say get user, you have to specify what user, so you might pass that through params. So params, or maybe you say user equals like Corey or something. Sometimes params can pass other stuff like authentications or other queries and stuff. Then we have two callbacks. So as we mentioned before, these are functions that you pass in. So when the GET request succeeds, it calls success callback. And additionally, you see it passes in a response. So when the function succeeds, it calls success callback and passes you the data from the GET request. And if there's an error, it calls failure callback. So the next question, how are these requests actually made? Does anyone see a specific object or tool that's being used to make these GET requests? Yeah.
XML HTTP.
Yeah, it's called XML Http Request. So this is kind of a built-in tool that's provided you by the browser. And what this does, it's just kind of built-in support that will let you send out HTTP requests. You might be wondering why it's called XML HTTP Request. So XML is like another data form. It looks like HTML. It's used to encode data and stuff. And it's been around forever. And when XML HTTP request was first introduced, I think it's called that because originally it was intended that you send out a GET request and it responds to you with XML data. But nowadays we don't really use XML anymore that much. Instead we're using JSON in today's lecture. But I guess just the naming stuck around. So that's why you see this name. Not very important, but that might be just in case you're wondering. And when the GET, I already mentioned this, but again, when the request returns a success, it returns to you the response text from the server. And if you're wondering, like, ready state equals 4, it's kind of cryptic, but like it's defined. If you look at the Mozilla documentation, 4 means the request is done and complete. Like, it's kind of arbitrary, but that's just how it is. So last question. This might be a trick question, but what do the get and post functions return? All right, if you look, they actually return nothing. So that's important to realize, is that when you send a GET request, this function will not return a value. Instead, it will pass the data through this callback function. And we'll see that when we get to some examples of how this works. So yeah, so this time we provided you with these methods. A lot of the time you'll have frameworks and stuff that will give you their own methods for making API requests. There's other options, like jQuery does this. There's another more modern method called Fetch API, if you're curious about that. But yeah, just keep that in mind. Anyways, so here's the API we're going to be working with today. It's going to be very simple. We're only going to be using these 2 endpoints. The first one is get stories. And then if you send a GET request to this, it's going to return to you a big JSON object of all the stories. So that basically means it's going to be an array. And every element of the array is going to be an object that has content, an author, etc. The second one is get comment. So for this endpoint, you pass in the ID of a story, and in response, it gives you the comments for that story. So 2 simple requests, and we're going to be playing with those in the browser. So let's start to test this API. So the first thing we want to do is open up index.html and just add these 2 scripts real quick so that we can test them actually working. Awesome. These 2. And then And then go ahead and open this in your open index.html in your browser if you want to follow along as I play with the GET request.
One thing to remember, guys, the order of this stuff matters too.
Yeah, that's true, because in feed.js, it's going to be using the functions defined in api.js. So you need to include API before feed.js. Okay. So once you have those two simple lines, in feed.js, so currently we don't actually have an API in the code we've written so far. So far we've only been writing front-end code, and the API is something that's defined by the backend. So for now we're going to be using the API from a finished version of Catbook, which is defined as API endpoint start. So if you would do, for example, API endpoint start plus API/stories, sending a GET request to that URL will return you the stories. So for now we're going to be using this. Well, I'll just show you how it works. So if you open up index.html, I'm going to open up a console here. Because we've included API.js, this GET function is actually defined. Actually, no, it's not defined. Okay, now it's defined. Okay. I just have to refresh. So let's do an example. So let's send a GET request to stories and see what happens. So first we need to do is get API endpoint start. So as I said before, so the URL, the website, so API endpoint start is going to be the actual server that's running our API. And on that server, we're going to access API/stories. This function takes no parameters because we're just saying get all stories. It doesn't really matter which ones. So we pass an empty object to represent no parameters. And on success, we're going to run this callback function. So on success, it's going to run this function and pass us stories as a parameter.
To make a new line, when you're in the inspector, guys, you have to do shift enter.
I didn't have to, but you might.
Oh, okay.
So yeah, so we're going to print out the stories. And notice there is another parameter for on error, which you can add another callback function if you want to, but you can also omit it if you want to. It's kind of optional because in the API.js, there's a line that says if the error callback exists, use it. If the error callback doesn't exist, whatever, just ignore it. So it's optional. I'm pretty sure this is going to work, so I'm not going to add one. So let's see. Okay, so it worked. So you see, this is a one big JSON object here, one JavaScript object. So look at all these posts. Okay, for this one, for example, it says "Hello World," posted by Aaron Sipser, and it has a unique ID. These are all the posts that we want to render to the page. And if you're following along, you should have the exact same posts. And our other route is called API endpoint start plus comment. And for this one, we're going to actually need a parent. So let's pick one. So let's do this post. ID is 5A, some random stuff. And we're going to see all comments that are underneath this post. And again, on success, we're going to run this function. Onto all our comments. And as expected, it returns these two comments. This is a test. All right. So eventually, when we render this to the page, it's going to have the story and then these two comments underneath it. I'll do this up just for a second. If anyone wants to get these work, but is having trouble, please raise your hand. All right. Cool. So these are also in the slides if you have those open. So let's take I want to take a brief slide lecture to talk about why we even bother using these callback functions, why we use this asynchronous behavior that Aaron mentioned before. So what if instead of what we used just now on the top example, what if it was like this at the bottom, where This looks a lot easier, it's a lot cleaner, there's no callback functions. You just send a GET request, and then instead of having a callback, what if it just returned you the value? And you could log it like that. Well, it turns out to do this, so this implies that every line of code would be executed one after each other in a synchronous fashion. So you would send this GET request, and they would wait for the GET request to come back before returning stories and moving on to the second line display on screen. Now, HTTP requests can take a long time. They might take on the order of a few hundred milliseconds or something. So that's a lot of time to be waiting. So if you imagine this, might be like the timeline of what's going on. You send the GET request at time equals 0. It has to travel over your Wi-Fi to get to the backend server. The backend server has to go into its database, pluck out all the stories, and send it back to you. Another trip over Wi-Fi. By the time it gets back to you, 200 milliseconds went by, and you haven't done a single thing. So you've wasted a ton of time. You could have been doing other stuff during this time, but instead you were just waiting. And then, so what if instead of waiting, we took care of this other stuff? Put that up there. Now you can kind of multitask. While you're waiting for GET to finish, do other stuff. So this is an example of what you can get when we talk about asynchronous behavior. Asynchronous meaning that when we send a GET request, we don't wait for it to finish. We move on to execute other code right away, so that we're not just wasting time. And then, when the GET request actually does finally resolve, we run this callback function displayed on screen. So as such, if you look at the order of which these lines execute in JavaScript, you might end up seeing something like this, where first, number one, you send the GET request. It doesn't wait for it to finish, so it automatically goes down to line other stuff, runs that, displays something else, does some other stuff, blah, blah, blah. And then sometime later, oh, the server finally responds, and it pops back up there to line 4 and executes the callback function. So yeah, just be careful that it might not always execute perfectly top to bottom as you read it. So let's take a look at why asynchronous behavior might be necessary. So I'm going to look at this completed version of Catbook. Inside the Google Chrome developer tools, there's actually another tab that we haven't used yet called Network. What this will do is it can actually show you all GET requests, all POST requests that are being sent by this website. You can see them. All right, so look at these. These are all the requests. Expand a bit. So the first request we do, we say get catbook.rover.com. Does that. Now once the index loads, we will say, oh, now I want to load, please give me feed.js, API.js, etc. Blah, blah. And then the page is going to send out this next GET request. All right, give me all the stories. Then once you get all the stories, now it wants to get comments. Now the comments is tricky because you need to send a GET request for every post. So for post 1, give me all the comments. For post 2, give me all the comments. Now, because we're doing this asynchronously, when you send the first GET comment request, it doesn't wait for it to finish. It keeps moving on and sends the second one immediately. And it doesn't wait for that to finish, it sends the third one right away. So basically, all these GET requests end up being sent at around the same time as you see in that timeline. Ultimately, about these 300 milliseconds later, all the comments on the page are loaded. Now imagine if this was not asynchronous, if everything was executed one after another. So you had to wait for this top line to finish before you could do the second line, and that to finish before you could do the third line. Well, in that case, it would take minutes for the whole page to load. It would be such a pain. So that's why it's critical when we send out lots of GET requests, do it asynchronously. And even if you have an even bigger site like Facebook or something, look how many, there's just tons of requests going by, like tons of images everywhere. Imagine if every single one of these requests you had to wait to do in sequence. It would take years to load Facebook. So maybe that's, hopefully that's some intuition on why this is necessary. Okay. So let's do, before we get into it, I want to really make sure we understand this point. So can anyone know what's one reasonable way that this might actually print out the screen? All right. So it's not going to print out top to bottom exactly because we have asynchronous behavior. Alright, so instead it's going to probably print out starting 1, starting 2, starting 3. Because when we fire off these GET requests, we're not going to wait for them to finish. So we're not going to execute the code inside them immediately. Yeah, so that's why it's going to fire off all these starting requests. Then it's going to probably pause for a second while the server processes the requests while they get sent back. And then later, actually you might not even get finish 1, finish 2, finish 3. It might be perfectly reasonable to get 2, 3, 1, or 3, 2, 1. So why is that? Even with this, the order is not guaranteed. That might be because, what if this API endpoint thing 1 returns to you a ton of data or something and it's slower. So maybe 1 ends up coming up last, even though you called it first. Or maybe your Wi-Fi just suddenly lags or something and post 2 comes 5 seconds later. I don't know, there's all sorts of things that could go on. But the point is that when you send a GET request, you don't really know how much time is going to go by before it calls the callback. So that's one thing to keep in mind, is that when you're using asynchronous behavior, you can't always make assumptions about what order things are going to execute. Even if you refresh the page 10 times, and you see it print this, maybe on the 11th time, it'll show something different. So, yeah. So, now what if you wanted to actually guarantee the order of things? Now, just because it's asynchronous, that doesn't mean we have no control over anything. So what if we did this? In this case, every time, I guarantee you're going to see starting 1, finished 1, starting 2, finished 2, starting 3, finished 3. Well, that's because when we send out the GET request for thing 1, it actually is going to wait for the callback to return before it starts number 2. So you see this right here. In the callback for data 1, we start get thing 2. And then we have to wait for the callback for data 2 before we launch thing 3. Anyone have questions about how this works? Okay. So in this case, the order is guaranteed. And if you want to nest a couple callbacks, that's perfectly fine, but you kind of want to be careful of this, because it can kind of get out of hand. So say you have 6 different API requests, and you need to strictly do them in order. Well, then if you write this, that's kind of disgusting. So this is a phenomenon known as callback hell. You have these callbacks within callbacks within callbacks. And at the bottom of the code, you have this huge cascade of squiggly braces, and it's really easy to get lost. And so this JavaScript's going to say, oh, you forgot a squiggly brace somewhere, and you have to spend 10 years trying to figure out where is it, because there's just so much garbage. So be careful about this. There's plenty of articles and stuff talking about JavaScript, dealing with callback hell, help me. And there's plenty of modern, JS technologies that will help you do this, like promises and stuff. But really, the main thing I would suggest is you can usually just design around it. If you have some kind of code that involves sending, 10 things one after another, you should probably kind of reconsider your design there.
So is this design still asynchronous? Because here you have these nested constructs, and so every GET request will be executed as the callback function of the previous GET request. And we know that the callback function only executes after you get the result of the GET request, right?
Right. So this is basically a way to force it to go synchronously, because you're forcing it to go one after another.
And so it is actually here synchronous, right?
I mean, every GET request is asynchronous because it's still using the callbacks, but we're using it in a way that makes its behavior synchronous. If that makes sense. Yeah. So, anyways, callback hell. You can nest callbacks, but just be careful and don't get too lost in it. Okay. So we're going to move on to a step 0. It's going to be a little bit of a warm-up exercise. So we're going to make sure we have your JS code included in HTML. We should have done it already. And add a call to render stories in index.js. So if you look at index, oopsie. Right now, index.js on the right, that's what gets called when your web page loads. So we want this to call our feed code, render stories. And then we want to make render stories, which is in feed.js, send a GET request, and print all those stories to the console. Let's not worry about DOM elements right now, but you should be able to get to a point where when you refresh the page, on the console, all the stories print out. So we can take a few minutes to try to do that. Yeah. If you have any questions, raise your hand.
And if you guys are confused, just follow along the solutions or raise your hand and one of staff will get to you.
Okay. All right, so now I'm going to move on a bit. I'll just quickly type these up myself so we know, just to be sure we're on the same page. All right, so first thing I'm going to do is add render story. Is that what it's called? Render stories to index.js, and then send out a GET request. So that is get API endpoint start plus API stories, and then no parameters, and it's going to return a function stories. Inside this function, we're going to just print out stories. Right. That should be it. So, if you want to get on the same page, you can run this code. Get reset and check out step 0, and then it will be synced up with the same code here. Yeah. I'll do the same thing. All right. Oh. All right. So I'm going to move on for now, but anyways, today's goal is going to be to fetch all these stories and comments from the API, and then create HTML blocks to display the data. So basically that's going to entail these 3 tasks. So in feed.js, render stories is going to make API calls and pass the responses to helper functions. And these helper functions are as follows. There's the first one, which is story DOM object, and it returns a story object, a story div. And there's another one, a comment DOM object function, which returns a comment div. So you'll see these 2 helper functions defined already for you in feed.js. They're empty. And our job is going to be to fill them out so that given a story object, create a new DOM object, a new HTML object that has the right things in it. So specifically, step 1 is going to be to display all the stories. So these can be done in 3 steps. So first, we've already done this. Fetch all the stories with an API request. So this part's already done. So now what we're going to do is for every story in this response, take a for loop through it, iterate through them. For every story, call the function story DOM object, I think it's called. And this function is going to return a new JavaScript, a new HTML object. So when you do document dot, create element or whatever it is, you're going to return one of those things. And we're going to take each of those story blocks and prepend it to a div called stories. So if you looked at index.html, there's this div here called stories. Oopsie. Right now it's empty, but what we're going to want to do is we're going to want to make new story objects and append it in there. Or actually, we're prepending it because we put stories that the most recent ones are at the top instead of at the bottom. So prepending it inserts it in reverse order. And then here on the right, we have an example of one story object. So we're going to have these 3 important fields to us, which is _ID, creator name, and content. We're going to take the ID and set it as the ID of a div. We're going to take the creator name and content and set them as an A tag, which is a link, and a P tag to the content. And then finally, we're going to initialize this little div for comments. We're not going to put anything inside of it yet. We'll do that later. But just make an empty div for the comments. So, this thing at the bottom, that's what we're making. So that thing at the bottom, that's what we're making. And you want to refer to Workshop 0 for the exact syntax of how you do this. How do you create a div? And how do you append it to the page? So, this is the first big step of our workshop. So we just take some time to do that. started again. Sure. Okay. So this first exercise was a pretty big step. You might have forgotten some of the details from workshop 0 about how to make divs, how to set IDs, and all that stuff. So I'm going to stop for a second. I'm going to start going through some of the code myself, just to get you guys a head start in case you were struggling at the beginning part. Alright, we'll keep the instructions up on the side if you've heard that. Okay, so the first thing we're going to do is start putting out the story DOM object function. So what this block of code is going to do is it's going to create a div that represents that whole block of code that we see on the bottom, right? And it's going to return that. So to create a div, the first thing we do is make a new story div is document.create element. I believe it is, yes, what it's called. And you say it's a div. So this is a new div object. Now at the bottom we're going to return the story div. We're going to do some other things in this, like as you see, it's going to have an ID that's like going to be the ID of the story. So to do this, we can use the set attribute function. So the story div dot set attribute ID and story JSON dot underscore ID. So you see, I have right here all this stuff. So this is what a story JSON is going to look like. So underscore ID. Yeah, that's equivalent to doing this, just in case you're wondering. Same things. And then we'll also need to set a class, which is going to be, I can't read it from here, but I have story and card. So story div dot class name equals story card. So that's the class. So that is how you would set up the first outer layer. If you want to add the inner divs, you can also make those divs and use functions like story div dot append, some other div, whatever. And it should be a very repetitive process that's similar to this. Now, what do we actually do with this function? Well, to do this, under Windows Stories, we're going to want to iterate through every object of the stories array. So, to give you an idea, so for I equals 0, I is less than stories weight size. So the current story is going to be stories array index I. And we're going to call story DOM object with this story JSON. And then with this thing, we want to actually put it into the page. So where does it go in the page? So if you look at index.html, down here, this div is where all the stories are going to go. It's called stories. So we want to get this element so we can put them inside it. So to do that, we use the function called getElementById. So const stories, like the stories container, or whatever you want to call it, or stories. I'm going to say document.getElementById, and it's called stories. Now I can do stories, something as simple as stories div.prepend this object that we just created. And that's going to put it on the page. If you run this code, it might actually show some, I think it's going to look empty. But, oh, you actually see it has added all the divs. See, if you inspect element, these are all the divs in the stories. We haven't actually, so it has all the IDs set correctly, the class set correctly, but they're completely empty, so that's why it looks like this. So the next step to do this is you just need to finish adding the rest of the elements as you see here. So you're going to need to add a new document.createElement A tag for the creator, document.createElement P tag for the content, and you have to append that to the story div. And then when you return it, it should render on the page. So I'll keep this up for now, and we'll have some free time to do this.
Is it that style to do like story div.id instead of using the set attribute method?
Does that work actually?
Yeah.
Does anyone know if there's a difference?
Be consistent.
Alright, that's fine.
So
most important than anything else is staying still with your own code, because if you can't read your own code, no one else will do. So if you're using set attribute, you try to stick to that. If you're using ID, then you just set everything else by that method.
Okay. All right. And again, if you have questions, raise your hand or use the question sheet. So yeah. All right. Anyone still working?
Start working.
All right. All right. I'm going to start going ahead and showing how to do this. Okay. All right. So range of stories. This function is complete. Now we just need to add other elements. I'll go through this really quick though. So the next element. So we have the next element inside here is going to be the card body. It says as card body. So just call this card body, and it's going to be another div. And what does it have? It has a class of card-body, so same thing as before. Card body.class name equals card body. And we want to actually add this to the story div. So append child card body. All right, and that should be simple as that for that one. Okay, the next one is a span where the creator goes. So let's something similar. Let's call that the creator span. And it's going to be a type span. In a creator span, we'll have a class name, which is story creator and card title. It is an A tag. Okay, so let's just. All right. And so story div that it's called core span, but whatever. Is a creator. Story div that append creator. And then there's going to be a next one where the content is going to go. Content is going to be a p tag, I believe. Oh, I forgot one thing. So the creator also needs to, of course, have the actual creator content in it. So creator.innerHTML. Let's use that function to set the content, which is going to be storyjson.creator name creating. So the content is another one, and its class is going to be story content in card text. And we need to set the inner HTML for this. Inner HTML. Like that. And add it. And finally, actually there's two more things. We need to add this card footer and that div inside the card footer. So let's add one here. Called card footer. It's here. It's a div, and the class name is going to be card-footer. And then the last div is going to be the comments div. It's also a div. Change it there. Change it there. And its class name is going to be story-comments, and it's going to have an ID. That is going to be the ID of the story plus dash comments. So if the ID is 5, it's going to say 5 dash comments. Set attribute. Story JSON. Dash comments. And that should be it. Okay, so I'm going to run this code, and it's probably not going to work. Let's see. Well, it does work. Okay. Kind of. I probably messed up one of the classes because the CSS is a little bit off. But yeah, so this is vaguely how it should look. Oh, you're right. So So these A, so that A tag and the P tag should not be in the story div, it should be attached to card body. And then the comments div should be under the card footer. Alright, now it's better. Okay. Does this make sense? Alright. Okay, so I guess with that we can move on to the last part, which is adding the comments. But first, if you'd like to catch up and get the code that I'm looking at right now, you can get reset hard and check out step 1, and we'll be on the same page. So I'll go ahead and do that too. So if you check out that, you can open up feed.js and look at the completed code for yourself. Okay, now finally, this is the last step of this workshop. And it's going to be to display all the comments. So it's going to be a pretty similar procedure. To be honest, you can probably just copy and paste most of the code from the first function and get it working fine. So it's going to work. So you're going to write code to get all comments for each story. So this is going to involve actually setting up a GET request for every story on the page. And then you're going to write code in comment DOM object to create an HTML block for this comment. And then append each comment to the correct story by using append child. Okay? And just like before, I've included what the API specification is so you can send out GET requests. And it's going to return an array of comment objects like this. So you can take its ID creator name, the parent, which is going to be the comment, which is the story that this comment belongs to, and its content. And like before, we're going to make this little div at the bottom and append it to the story. I just want to clarify, just in case you're wondering what the parameters means. So that is when you send a GET request, the second parameter is for params. And it's going to be a JavaScript object where parent colon the ID of the story. So that's what you pass in the GET request. I think now, because we only have about 10 minutes left, I'm just going to start typing out this code and you can follow along if you haven't gotten it yet. Alright, so should I get started? Oh, fine. Alright, so I'm going to start typing up the comment DOM object. Feel free to keep working or follow along. So this comment DOM object, so first we need to make a comment div. It's going to be very story to the stories div. So document.create element. It's going to be a div. This comment div. It's going to have an ID in the class name, just like the other ones, as specified up there. Set attribute ID to comment JSON dot. I think it's that ID. Yeah. And then the next element that goes inside, there's two things. There's an A and there's a span. So creator equals creator is document create element by ID. That's this A tag, and it's going to have a class name of comment-creator. And it's going to have inner text that is going to equal the creator name. So that's going to be comment JSON dot creator name, as we see up here. And finally, use just the final div element, that is the content div. Or span rather. And that's going to have class name of comment content, and the inner text is going to be content. And finally, we need to add the creator in the content to the comment div. So comment div.append child creator, and add child content. Okay, and that's about it. Now we just need to return the comment div. Okay, so this part is basically how it should be done. That's pretty similar to the last part. And then the other component is sending out the GET request for these comments. Also going to be similar. So note how you need to actually have the GET request for the stories complete before you can start setting up a GET request for the comments. Because in order to request the comments, you need to know what parent story to use. So that's why I'm going to put it inside the callback function and inside this for loop. So get API endpoint start at the comments. Not sure why it's comment instead of comments, but so the parent we're going to set as current story.id. Yeah. So that's the parent story for which we're going to find all of its comments. And when it succeeds, we'll get the comment div, comment array. This line's getting real. Okay. So we'll get the comment array, and similarly, we also want to iterate through all these comments. And for each comment, stick it onto the story, to somewhere on the current story. So for let's do a different variable name. For let j equals 0, j is less than comment array length j plus. We're going to find the current comment is comment array index j. Or let's just call it comment JSON, because that's what this really is. It's the JavaScript object. So for each of these, just like before, we're going to call a comment DOM object, just like story DOM object, with the comment JSON. And to do this, we want to stick it on to the div we made. We made it, where is it? This one. This story comments div that we made in the previous part. We want to take the comments and put it under that div. So to do this, we're going to need to grab this div, get it by its ID, which is the story's ID dash comments. So let's put this. So the comments div, or whatever you want to call it, is going to be the div that contains the comments for this story. So it's going to be current story, its ID. Actually, let's do it this way. So each comment also has its own parent as one of its attributes. So you can do comment JSON dot parent. So that's the ID of its parent, plus dash comments. Okay. So now we have this comments div. We want to append the child. All right. So once again, what we get here is we got the div for the containing story, and now once we have that div, we want to stick our new comment inside of it. So let's see if this does anything. Oh my God, 24. I'll get that. Oh, so document.getOutInfID. Okay, and here's some comments. I probably messed up some of the CSS or some of the class names because it looks kind of off, but that's basically what it should be. I think I need to add the colon or something. Now it looks a little better. I added a colon there. You can play around with it and then try to figure out to make it look better. But that's basically how it should look. Yeah, so finally, if you call this, git reset hard and git check out step 2, you can get a copy of this finished code and see how it looks. So it's git reset hard, git check out step 2. Okay, and it looks the same. So we did fine. Okay, so good. So overall, that's the end of this workshop. So we learned how to make API calls today, which is nice, and we got to review some of yesterday's lecture material in creating JavaScript DOM elements. And along the way, we had a nice side lecture about asynchronicity, so you know to be careful about JavaScript's behavior and not always expect things to run line by line, top to bottom. So, and we made a nice cool story feed page, so good job everyone. All right, so now we're gonna, the last hour, we're gonna start talking about backend stuff.